Hello everyone, welcome to Parthiba Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 7th May 2023. The problem statement for today is string mirror. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it says, you are given a string str of length n. You want to choose a non-zero integer k such that k less than or equal to n such that you can perform the following operation. Take the prefix of the string of length k and append the reverse of it to itself. Your task is to find lexicographically smallest string you can get. Okay, so the problem is to find the smallest palindrome string that can be obtained by appending the reverse of a prefix of the input string to the input string itself. Okay, so let's go through the given examples here. So the first example says the given string is this one, where it contains character like B, V, D, F, and D, K, N. Okay, so here the output is set as B. Output is BB. So here this output is lexicographically smallest string you can get. If you choose k greater than 1, the order of the resulting string will increase. So here we can see that so the first character is B, but if you look at the next character, so it is V, which is much greater than B. If you look at it lexicographically, then B comes earlier, V comes later. So if we include V, then we will not get the lexicographically the smallest string. That's why we are just checking that if any character which is occurring next to it, if it is greater, then we are avoiding that. We are restricting to that limit only, to that position only. So since B is the starting one and the next character is greater than B, so that is discarded. So only B is considered. So we are taking the reverse of it and appending to B. So the reverse of B is B itself. So the output is B and B, BB. Okay, that is asked in the problem statement, that we have to take the reverse of the string and append it to that prefix itself. So when we look at the second example says a string contains CASD. So here the output is CAAC. So here in explanation it is said CAAC is the lexicographically smallest string we can get. So here what we will do, so again we check, we starting from C, then we check if the next character whether it is smaller than C or greater than C. So here we can see A is smaller than C. So now we can add A to C, considering that now the substring or the prefix contains two characters. Because if we take just only C and when we try to add the reverse of it to itself, then it will become CC. And now we have got C and A. So now when we take reverse of it and add to itself, then it becomes CAAC. So if you look at it, if you look at both of these, that means CAAC and CC lexicographically, then CAAC is much smaller than CC. Lexicographically means the way it is arranged in dictionary. So if you have two words there, CAAC and CC, then you will find CAAC comes much before than CC. So that's why we are following that. But after A, we see that S is there. S is greater than A. So we restrict up to A only. So our output will consider the prefix up to CA only. Then we reverse it and add it to itself. Okay. I hope both the given examples are clear. So the approach that we will be using to solve this problem is to first find the lexicographically smallest prefix of the given string, then append the reverse of this prefix to itself to get the final lexicographically small string. To solve this problem, we can start by iterating through the input string and keep track of the longest decreasing prefix of the string. We can do this by comparing each character of the string with the previous character. If the current character is greater than the previous character, we break out of the loop since we found a non-decreasing substring or the prefix. Once we have the longest decreasing prefix of the string, we can append the reverse of the prefix to the end of the string to obtain the smallest palindrome. Okay. Here you can see whatever the output we are getting, that is the palindrome string, because we are appending the reverse of the string to itself, so it will always be a palindrome one. Okay, so this is, with this approach we'll be solving this problem. So there is nothing much to explain it with some other thing. We just have to see, iterate through the characters one by one, and where so from each character, if we continue to find the next character is smaller than the current one, then we continue adding it to the prefix, else we break out from the loop, and whatever the value we get, we just do a reverse of it and add it back to the string. That means add it back to the prefix string, so that will be our smallest palindrome, or the lexicographically smallest string which we can get. Okay, so with this approach only I have solved the problem. Let me just copy the code here. Actually the solution is pretty simple. Here I have added comments against each line so that it becomes easy in understanding. So what we are doing, first we are creating a string builder. First I am solving in Java, so creating a string builder to store the prefix of the mirrored string. So whatever the prefix we are getting, which is valid according to the given condition in the problem, that we are appending in the prefix. So first we are creating this string builder, then first we are adding the first character to this, then for the remaining characters we iterate through this loop. There we, and here we are starting from 1, and it will go up to length of the string. So the current character will get by string.caret of I, and the previous character will get by doing str.caret of I minus 1, because here we are starting from index 1. Once we get both these characters, then we compare. If the current character is greater than the previous character, see here in the first example, here B was the first character and V was the second character. So the current character here, when we are starting from index position 1, it is V. So here we are checking if current character, which is V, is greater than the previous character, which is B. Yes, we have here this condition is true, so we are breaking from this loop. This means that we have gone past the mirror point. That means whatever was the valid mirror point, we have crossed that. So we are breaking from this loop. Another condition we are checking, if the current character is equal to the first character of the input string. If this is there, then we also we break from this point of the loop. We have reached the end of the valid prefix of the mirrored string, because if the characters are repeating there, then it will be always be the same there. So that will mark as the end of the valid prefix for the mirrored string. So we break even for that. If both these conditions are not true, then whatever is the character we are getting, that is actually the smaller than the previous one. That means the current character is smaller than the previous one. Then in that case, we add that current character to the prefix. Okay, and this will be repeated for all the characters in this array. Okay, until we break out from this loop or this loop terminates. Once this is done, then whatever is the prefix which we have got there, so first we are converting it into a string builder so that we can perform reverse operation to it. So converting this prefix to a string builder, then creating a reversed prefix of this mirrored prefix, whatever we have got in the previous step, and we are calling the reverse function to it, so that we will get the reverse of the prefix string which we have got so far. So whatever is the reversed string which we have got, that we are storing in reverse prefix, and this reverse prefix is we are adding it back to the mirrored prefix. So whatever is that mirrored, whatever is the prefix which we have got from this loop, so to that we are adding the reverse of it, and we are returning the same. Okay, so that's it in the solution part of it. So actually the solution is very easy. We are just appending the first character, then we check whether it is following the trend of the current character smaller than the previous character or not. If it is not, then we break out of the loop, else we add the current character to the previous we add current character to the prefix. And once this is done, that means either we break out from this loop or this iteration completes. Then whatever is the value which we have got in prefix, we are converting it to string builder, performing a reverse operation to it. Whatever we get as the output, we add it to the mirrored prefix and we return the same. Okay, so let me try compiling this code. So here we can see we have got correct output for this given input. Let me try submitting this solution in Java. So here we can see it has covered all the test cases. So this problem has been solved successfully in Java. When we talk about the time complexity of this function, it is in the order of big O of n, where n is the length of the input array. The first operation where we create the string builder object, it takes big O of 1 time. Then the loop iterates over the string starting from the second character to the end, which is this one, which takes big O of n time. Inside this loop, we perform some constant time operations like caret and comparison operation, which takes big O of 1 time. So the total time complexity of this loop is big O of n. But when we come out of this loop, then we create a string builder object for the mirrored prefix, this one, which takes big O of 1 time. We reverse the prefix using string builder reverse method, which takes big O of n time. Then we append the reversed prefix to original prefix, which also takes big O of n time. So finally we convert the string builder object using toString method, which takes big O of n time. So the total time complexity of this function is big O of n plus n plus n, which is in the order of big O of n only. Okay, so the time complexity is big O of n. So this was the Java solution. Let me move to C++ editor. Even I have prepared C++ solution. Let me just copy it here. Logic is again the same, only syntactical difference between C++ and Java that is there. Here also we are creating a prefix string. We are appending the first character to it. Then starting from index 1 up to the length of the string, we extract the character, the current character and the previous as the previous character, and we check if current character is greater than previous character, then we break, and if the current character is equal to the first character, so that means again we have crossed the valid prefix point. That means the characters are repeating now, so we again break. If these two conditions are not true, then we keep on adding the current character to the prefix. So once this is done, then whatever we have got as a prefix, we just do a reverse of it and we add it back to the mirrored prefix and we return the same. The logic is completely same. Let me try compiling this code. So with this C++ code also we have got correct output. Let's submit this solution. So even with this solution, we can see that it has passed all the test cases. So this problem has been solved successfully in both languages, that is C++ and Java. So I'll provide the link for this question and the link for the solution code in C++ and Java in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.